Do you ever wonder if we are alone in the universe? Well, the discovery of Proxima b, an exoplanet orbiting our nearest star, has brought us one step closer to finding out. As scientists continue to uncover the secrets of this mysterious world, we are beginning to understand more about its potential habitability and the possibility of extraterrestrial life. So buckle up and join me on a journey through the latest discoveries about Proxima and what they could mean for the search for life beyond our solar system. What is Proxima b? The closest alien planet to our solar system is even more Earth-like than scientists had thought, new observations suggest. In a new study, an international team of researchers found that the minimum possible mass for Proxima b, which lies just 4.2 light-years from Earth, is just 17% more massive than our planet. Previously, scientists thought that this exoplanet, which lies in the habitable zone of its star, harbored a minimum of about 1.3 Earth masses. The new measurement indicates that Proxima b could be even more like our home planet, at least in size, than previous observations led scientists to think. First detected. Proxima b was first detected 4 years ago by an older spectrograph, HARP-S, High Accuracy Radial Velocity Planet Searcher, which is installed on a scope at ESO's La Silla Observatory in Chile. But with these newer observations, scientists have an updated, ultra-precise view of the planet. An alien planet. So what's the deal with this Earth-sized planet? Proxima b is one of the most interesting planets known in the solar neighborhood. Alejandro Suarez Mascarino, the lead author of this study, said in the same statement, "This strange alien planet orbits Proxima Centauri, the closest star to our Sun. Because the planet orbits right in the middle of its star's habitable zone, it's possible that liquid water, and potentially even life, could exist there. Because of its Earth-like mass, scientists believe that liquid water could exist on Proxima and be a rocky, terrestrial planet similar to Earth. But Proxima orbits around a star that, while close to our solar system, is also much dimmer and much less massive than our Sun. Researchers think that the exoplanet is tidally locked and in synchronous rotation with its star, meaning that one side is always facing the star and one is always facing away, a light side and a dark side. In addition, it needs to be clarified if Proxima b has an atmosphere. The planet lies very close to its star, completing one orbit every 11 Earth days. Some researchers think that radiation coming from Proxima Centauri might have stripped away Proxima b's air, making it impossible for the alien planet's surface to hold onto liquid water. As scientists continue to study this system with new and better technology, we will be able to better understand what it's really like. Proxima Centauri is located within the classical habitable zone of its star and receives about 65% of Earth's irradiation. Its equilibrium temperature is estimated to be about 234 K, minus 39 degrees Celsius, minus 38 degrees Fahrenheit. Various factors, such as the orbital properties of Proxima Centauri, the spectrum of radiation emitted by Proxima Centauri, and the behavior of cloudsil, and hazes influence the climate of an atmosphere bearing Proxima Centauri b. There are two likely scenarios for an atmosphere of Proxima Centauri b. In one case, the planet's water could have condensed, and the hydrogen would have been lost to space, which would have only left oxygen and / or carbon dioxide in the atmosphere after the planet's early history. However, it is also possible that Proxima Centauri b had a primordial hydrogen atmosphere or formed farther away from its star, which would have reduced the escape of water. Thus, Proxima Centauri b may have kept its water beyond its early history. If an atmosphere exists, it is likely to contain oxygen-bearing gases, such as oxygen and carbon dioxide. Together with the star's magnetic activity, they would give rise to aurorae that could be observed from Earth if the planet has a magnetic field. Climate models, including general circulation models used for Earth's climate, have been used to simulate the properties of Proxima Centauri's atmosphere. Depending on its properties, such as whether it is tidally locked, the amount of water and carbon dioxide, several scenarios are possible. A planet partially or wholly covered with ice, planet-wide or small oceans, or only dry land. Combinations between these are scenarios with one or two eyeballs, or lobster-shaped areas with liquid water. Stability. Strong irradiation by UV radiation and X-rays from Proxima Centauri constitutes a challenge to habitability. Proxima Centauri receives about 10 to 60 times as much of this radiation, especially X-rays, as Earth. It might have received even more in the past, adding up to 7 to 16 times as much cumulative X-UV radiation than Earth. UV radiation and X-rays can effectively evaporate an atmosphere since hydrogen readily absorbs the radiation and does not readily lose it again, thus warming until the speed of hydrogen atoms and molecules is sufficient to escape from the gravitational field of a planet. They can remove water by splitting it into hydrogen and oxygen and heating the hydrogen in the planet's exosphere until it escapes. The hydrogen can drag other elements, such as oxygen and nitrogen, away. Nitrogen and carbon dioxide can escape on their own from an atmosphere, but this process is unlikely to substantially reduce the nitrogen and carbon dioxide content of an Earth-like planet. Stellar winds and coronal mass ejections are an even bigger threat to an atmosphere. The amount of stellar wind impacting Proxima Centauri may amount to 4 to 80 times that impacting Earth. The more intense UV and X-rays radiation could lift the planet's atmosphere to the outside of the magnetic field, increasing the loss triggered by the stellar wind and mass ejections. At Proxima Centauri B's distance from the star, the stellar wind is likely to be denser than around Earth by a factor of 10^1000, depending on the strength of Proxima Centauri's magnetic field. As of 2018, it is unknown whether the planet has a magnetic field, and the upper atmosphere may have its magnetic field. Depending on the intensity of Proxima Centauri B's magnetic field, it can penetrate deep into the atmosphere of the planet and strip parts of it off, with substantial variability over daily and annual timescales. In conclusion, Proxima b represents a fascinating glimpse into the vast and mysterious expanse of space beyond our solar system. While much is still unknown about this potentially habitable world, what we do know is awe-inspiring. From its proximity to our own sun to its rocky composition and potential for liquid water, Proxima b holds the promise of being one of the most habitable exoplanets yet discovered. If you found this video informative, make sure to hit the like button, share it with your friends and family, and subscribe to our channel for more exciting content like this.